Hello. As a part of Advanced Network Security Part 2, for the video log submission, my topic is Dynamic Source Routing (DSR). The Dynamic Source Routing Protocol is a simple and efficient routing protocol designed specifically for use in multi-hop wireless ad hoc networks of mobile nodes. So by multi-hop, there is no definite hops that they have to follow, and the network can be wireless. DSR allows the network to be completely self-organizing and self-configuring without the need for any existing network infrastructure or administration. It is a reactive protocol, and all aspects of the protocol operate entirely on demand basis. It works on the concept of source routing. Source routing is a routing technique which the sender of a packet determines the complete sequence of nodes through which the packets are forwarded. The advantages of source routing is basically that the intermediate nodes do not need to maintain up to date routing information in order to route the packets they forward. The protocol is composed of two main mechanisms of route discovery and route maintenance. DSR requires each node to maintain a route cache of all known self to destination pairs. So every node will maintain a cache, okay, a cache of all the routes for all the known nodes. Okay, for intermediate nodes, if they know the path from them to the destination, so they will store this path in this route cache. If a node has a packet to send, it attempts to use this cache to deliver the packet. So whenever they have any packet and they want to send it, they will first refer to this path cache. Okay, this cache of all the known paths from particular node to the destination. If the destination does not exist in the cache, then a route discovery phase is initiated to discover a route to destination by sending a route request. So once they refer this route cache, okay, and they do not find the path to the destination, this time is they will send a packet, or they will start a phase that is route discovery phase. Okay, that is initiated to discover a route like to the destination. This request includes the destination address, source address, and a unique identification number. So the request, this route discovery request that we will send, that will include three things: the destination address, the source address from the where it is sent, okay, and the unique identification number. If a route is available from the route cache but is not valid anymore, so if it expires, okay, the routes have been changed and it is the current available route in the route cache is not valid, a route maintenance procedure is initiated. A route reply is generated by the destination or by any intermediate nodes when it knows about how to reach the destination. So if any node comes to know, reaches the destination and comes to know that this is the path that they will have to follow, they will generate a route reply packet. Okay. Next is, there are a few advantages and disadvantages of DSR. In advantages, DSR uses a reactive approach which eliminates the need to periodically flood the network with table update messages which are required in a table driven approach. So there they don't have to after every time they don't have to flood the whole network path, whole the network address and information in a table. Okay. The intermediate nodes also utilize the route cache information efficiently to reduce the control overhead. So it reduces the control overhead as well, because the intermediate nodes already have this route cache with them. Disadvantages of DSR is that route maintenance mechanism does not locally repair a broken down link. Okay, so it will not be repaired locally. Like there would be nodes that have to send this route maintenance packet. Okay, the route maintenance is initiated for this. The connection setup delay is higher than in table driven protocols. Even though the protocol performs well in static and low mobility environments, the performance degrades rapidly with increasing mobility. Also, considerable routing overhead is involved due to the source routing mechanism employed in DSR. This routing overhead is directly proportional to the path length. So there are a lot of overhead as well. So that's one of the disadvantages of DSR. So now we will see a demonstration of this DSR protocol, okay, for which we will be using ns2 simulator. So ns2 simulator is configured in my cloud machine here, and I'll give you a demo of first how to generate those. So we generate a TCL code like this, if you can see, right? I'll show you in text editor. Okay, so this is a code that is run by the simulator to demonstrate this how DSR work here. Okay, so in this I can explain you, like there are various variables that are initialized in this code, like how many nodes. This NN is the number of mobile nodes that will be in my network. Okay, then the antenna model, what will be used, the channel type, what is the MAC address, the link layer type, okay, dimension of the topography, like it will be 500 cross 400, okay, time for stimulation to end, okay, then it will set the new simulator, okay. There is also NAM. There are various type of file created, like NAM file is created, trace file is created, okay, and this is a wireless, demonstration. So we can also have wired if you want, okay. Then there is node configuration, what we have configured: ad hoc routing, L type, MAC type, prop type, channel. Everything is, if it is on or off, you can use it, like keep it as per your requirement. Then where will be the nodes initially be, this is the position, okay, like for current there is 5, x is 5, y is 5, z is 0. Then this is the position for node, second node, like n1, and there is a position for n2. There is generate movement, so this all specifies when, at what time the node will start moving, okay. Then what the coordinates it will move till, like that. Then there are agent definition, like they have used TCP and TCP sync here. And then also, like at what time the simulation starts happening and what it stops. So this is all code that is in the TCL file, okay. So how is it generated, how this TCL file is generated? So I can show you, this is NSG tool which we can use to generate the TCL file. I can show you here. First we'll go to desktop, okay. Here I have this NSG 2.1 jar, okay. So to run this I will need Java jar NSG. Okay. So this opens my NSG tool. Here, which type of scenario do I want? Do I want a wired scenario or I want a wireless scenario? So we have seen in our introduction, DSR is also in wireless, so we'll choose wireless here. Now first there are various things: node, agent, application, parameter, TCL. Okay, what does these do? First is node. Here I'll choose the position of my nodes, n0, n1, n2, like we saw in that file, right? That n0 was in position somewhere, x was 5, y was 5. So we can change this later in our code directly, right? So for this, just I am showing you how to create it. So we have the position of n0, n1, n2. We can change it later. Okay, now what I can do is I can select this, okay, and select various, when will the movement of the node starts, okay, and at what speed it will move, okay. So I can just consider that movement starts at 10 seconds, okay. Destination could be 250, okay. Then it would be 250, or it will move at a speed of 3. Okay, I'll add it again if I want. Okay, it will move again, like after reaching this position it will move again back. So I can again show live here how we can move it. Okay, so I can move it to 480, 300, and it will move a bit of different speed at 5. Okay, and I'll add it here. So this is done. Also I can check same for node 1 is a waypoint. When it moves, it will move at 15. Destination would be, I can say, 445, 345, 285, 285, and with a speed of 5. So this you can change as per your requirement. Okay, I'm just following as we saw there a document, right, for DSR. So I'm just using some information from that text on that TCL file only. Okay, here I have given this. Now okay, I want what type of agent I want. Okay, so when we can select anything. So currently let me use Urano to this. Okay, then TP sync I can use here, and we need to connect the TCP sync with the each node. Okay, application we can use this. Here I can give stop time is 150. Okay, start time I can give, you can start at 5. Okay, and I can give this FTP. Now what we can do is check parameters. What are in parameters? There are several parameters, right? Simulation time, we should see that if we have given the stop time at 150, simulation time should be at least more than that. So we have 160 here. Okay, I can give whatever name I want of this. Then wireless, the configurations we saw, right? What is the channel type, we can select it from here for the code. Routing protocol you can change. If you want DSR, you want AODV, okay, or you want DSDV, you can all change from here. So currently we want for DSR. Then next is channel. Here also there is some information. We'll keep it as save as default. Done. Now we want the TCL, so we'll just click on TCL and this generates our TCL code. So we can see here this. Okay, so we can change if the dimension we want to change. So we can change the dimension to 500. Okay, our dimension has been changed to 500. Now what all we can change, we saw in that group, right? The nodes are, I can give nodes as this position of the node 0, 5, 5, 0. So I am just selecting this so that I could show you how it behaves. Okay, I have this for node 1. What we saw is it is 490, 285, 285, 0. Also this is 150, 240. Okay, 0. So this is our coordinates. This is the movement code, when it will start moving. Okay, so this is our code. Now we can save this as at the desktop with file called ns2 vlog. Okay, we can save. Once we save here, go back, create duplicate. Okay, we'll start a new terminal here. We'll go to C desktop. Okay, and see we have we have the ans vlog tcl here, right? So we'll just give ans vlog and run it. So it creates, you can see it creates a file of trace and nam here. Now we'll just run this nam file. We can run ans log nam. Okay, it created with a different name, right? We say, right, trial dot nam. So we'll choose that and we'll run. So we have this window open here. We can create it. Okay, let me just send this. Okay, I play this and increase the speed of the simulation. Okay, see, so it starts moving, you can see at 5. Now it will start communicating, but they are communicating through node 2. Okay, that we have not moved. Okay, so both n0 and n1 are moving, but they are communicating through node 2. When they are near each other sufficiently, they are directly communicating. Now they don't need this node n2. Okay, they are communicating directly. Okay, then again when they'll be sufficiently far away from each other, you can see they are far. Okay, in this maybe I have not given simulation for that time, but same I can show you with my the already file that I have generated, right? I can show you with that. Wait a second. Okay. ns exp tcl. Okay, so if you see this here, and this is the same thing. Okay, I just created it earlier. Okay, this I have run. I have given the speed to, okay, see now a bit faster. Yes, okay, so they are coming close, they are moving, they start communicating, but they are communicating through node 2 again, that we already saw. Now they are close, they are communicating directly. Okay, let me reduce the speed here. See, now when they'll start communicating now with again back through node 2. Okay, again they'll stop communicating directly when they're far enough, like they can't reach each other. They'll start communicating through node 2, because node 2 is in their circle, in their network. Okay, so this is how DSR protocol works. So this was the presentation for DSR routing protocol. That's it for the topic. Thank you.